Good morning, students. We will see some MCQs in this chapter. First of all, we will start MCQs from chapter number 11. That is thermal properties of matter that we have discussed last chapter. Okay. Yes. First of all, to solve any MCQs, you have to remember equations. If you have a list of equations, then you can easily solve MCQs. First question. You are given one figure. See, this figure is, what is description of this figure actually? It is one composite slab made up of two parts. One part having thermal conductivity K, thickness X. Another part having thermal conductivity 2K and thickness 4X. Okay, so yes, these two parts are connected in series to make one composite slab. And points. This point, this end having temperature T2, this end having temperature T2, T1, and T2 is greater than T1, means it is hot and T is cold end. So obviously heat is transferred from T2 to T1. The rate of heat transfer through the slab is A, T2 minus T1, K, X, F. Then you have to find what is value of X. What is value of X? See, yes, you are given equation of heat transfer, rate of heat transfer. Yes, you are given. But we will find equation of rate of heat transfer by our method. And then we will compare this given equation. So method is easy. Okay? Chalo. How to find rate of heat transfer? What is its equation? Rate of heat transfer. Its equation H, or we can say this dq upon dt, dq upon dt is equal to K A T2 minus T1. Why T2 minus T1? T2 is greater than T1. Divided by L. It is one general equation. Hello, remember it is one general equation. Okay, so I can write this as T2 minus T1 upon L upon K, or you can write H is equal to T2 minus T1 upon RH. Yes, you know L upon K is called RH, that is thermal resistance. Now T2 and T1, T2 is temperature at this end, T1 is temperature at this end. So what is RH? RH is the whole resistance of composite slab. So yes, RH is resistance, thermal resistance of composite slab. So how to find this RH? How to find this RH? So I will write RH is equal to, see, you are given that this composite slab is made up of two parts. This one part and this another part. See, this and this, they are same. Means cross-sectional area is same for each part. Cross-sectional area is same for each part. As heat is flowing in this direction, we can say that these two parts, these two components are connected in series. And for series connection, what is equation of resistance? If resistance of this part is R1, if resistance of this part is R2, then resistance of composite slab RH is equal to, it is R1 plus R2. Clear? Okay? It is general equation. RH is thermal resistance of composite slab and it is made up of two parts. So RH is equal to this R1 plus R2. Now how to put values? So RH is equal to R1. What is resistance of first? What is resistance of first slab? Yes, you know equation of thermal resistance. That is RH is equal to, it is L upon K, as shown in here. Okay, L upon K. L means length. Chalo. What is length of this first part? It is X divided by K. What is thermal conductivity of this? It is K. What is cross-sectional area of this first part? It is K. Plus R2 is for this second part. Its resistance. What is its length? Its length is 4x divided by, what is its thermal conductivity? 2K. What is its cross-sectional area? It is K. It is K. So yes, RH is equal to this x Ka plus 4x upon 2Ka. So I can say here it is 2, here it is 2. Ka, K denominator same. So it is x plus 2x means it is 3x. So RH is equal to it is 3x upon Ka. And down. So it is value of RH. Simple. Okay, as this composite slab is made up of two parts, its equivalent resistance RH is equal to R1 plus R2 with the help of this data. Okay? Okay. Now put value of RH in this equation. Therefore, H is equal to it is T2 minus T1 upon what is value of RH? You have to put value of RH, that is 3x divided by Ka. So I can write Ka in numerator. Ka in numerator. So it is the equation that we have obtained. It is the equation that we have obtained. Now what is equation given? Here it is. Here it is. This equation that we have obtained. And this equation of heat transfer, this one, H. So it is A T2 minus T1 K upon X and here F. That is given. Now compare these two equations. Hello. Compare these two equations. So see, H is equal to H is equal to T2 minus T1, T2 minus T1, Ka, X. Then what is value of F? It is 1 by 3. If you compare this, you will get value of F. F is equal to 1 by 3. So yes, it is your answer. Simple. Okay. So yes, for heat, you can remember this equation. Or to solve such questions regarding composite slab, you can also remember this equation. That is H is equal to T2 minus T1 and RH means total resistance between these two temperatures. Simple. Any doubt? Okay, so it is one question. It is how to find the rate of heat transfer. Second question, yes, it is visible on board. Okay, what you are given? You are given to concentric sphere having radius R1 and R2. Temperature inside it is here T1 and here it is T2. Your question is, what is the radial rate of heat flow in a substance between two concentric spheres? Due to temperature difference, heat will flow. So that heat is flowing from higher temperature to lower temperature. Suppose I am assuming that T1 is higher temperature, okay? So yes, heat will flow in radial direction in this direction. Then your question is, what is the radial rate of heat flow in substance between two concentric cells and it is proportional to which quantities? It is proportional to which quantities? So what is equation of radial rate of heat flow? And this radial rate of heat flow, it depends on T2 minus T1 upon RH. Yes, we know what is temperature difference. First of all, we have to find what is the resistance between these two spheres. What is resistance of object? L upon K. K, that is same. L, that is distance. Okay, but A, that is area. So area continuously from this center it changes, and due to that we have to use method of integration. We have to use method of integration because this area is not constant. If you move from R1 to R2, if you move from R1 to R2, then how to find this? See here. I am assuming this sphere is made up of small elements. For example, like this. One shell, like this. One shell like this. Okay, that it is one shell. Yes, it is one shell. At distance x and its thickness is dx. Okay, so take one element. Take one element. Take one element at distance x from center having thickness dx. And which element? This element is one shell. Okay, shell at distance x means its radius is x. So first of all, I will find okay, what is the resistance of this shell. So resistance of element means this shell. I will write it here. Okay, what is the equation of thermal resistance? Yes, R is equal to L upon E. L means length through which heat is passing. So yes, it is the length through which, it is the thickness through which heat is going. So it is dx divided by K, that is thermal conductivity. It will remain same between the material, so it is K. And A, that is area from which heat is passing. So yes, at it is shell, its area is 4 pi x square. Clear this equation? Resistance of element, that is shell. Okay. Now to find the total resistance between two concentric spheres. Okay. So therefore, resistance between two concentric sphere, the resistance between two concentric sphere, that is R, is equal to this integration dr is equal to integration dr. Here it is integration. What is the value of dr? It is dx upon k 4 pi x square. Now x, integration is with respect to x. What is x? It is radius of this shell from center or distance. Now as we have to find total resistance between two concentric elements from R1 to R2. So what is limit? It is from R1 to R2. It is from R1 to R2. Yeah, K 4 pi constant. So it is 1 upon 4 pi K constant. Okay, it is integration R1 to R2. 1 upon x square dx. 1 upon x square dx. So is equal to, it is 1 upon 4 pi K. What is integration of 1 upon x square dx? Yes, it is minus 1 upon x. Minus 1 upon x. Limit is from R1 to R2. How 1 upon x? Okay, we have already discussed. Okay, or if you don't know, then I will write here. Okay, integration 1 upon x square dx is equal to integration x raised to minus 2 dx is equal to x raised to minus 2 plus 1 power minus 2 plus 1. So is equal to x raised to minus 1 upon minus 1. This minus I can write here and it is 1 upon x. So yes, this integration you have to remember. Okay, so is equal to, it is 1 upon 4 pi k minus 1 upon x r2 r1. Now put limit, that is r2 to r1. So 1 upon 4 pi k. If you write minus here outside, then it is 1 upon r2 minus 1 upon r1. And out, or you write this minus inside, then you can write this 1 upon 4 pi k. Here it is 1 upon r1 minus 1 upon r1. Any doubt? Any doubt? Okay, now if you simplify this, so see, here h is equal to, no, not h, is equal to, it is r is equal to, so r is equal to, it is 1 upon 4 pi k, 1 upon 4 pi k. Here it is r2 minus r1 upon R1. Yes, it is actually equation of resistance. We don't have to find rate of heat transfer. So H is equal to, it is temperature difference T1 minus T2 upon R. Here I am assuming okay, T1 is greater than T2. That's why I have to write T1 minus T2. Now if you put value of R, then H is equal to T1 minus T2 upon R. Upon R means here it is R2 minus R1, and this denominator I can write in numerator, means here it is 4 pi k R1. Clear? To see this, if this temperature difference is constant, 4 constant, pi constant, k constant, then I can say here H is proportional to R1 R2 upon R2 minus R1. You have to find this. Okay, and now for this concentric spheres, due to them, you have to remember this equation of heat flow, that H is equal to it is T1 minus T2 4 pi k R1 R2 upon R2 minus R1. Remember this equation. Okay, yes, from this MCQs are possible. Yes, from this MCQs are possible. Yes, MCQs are possible. Clear? Okay, so yes, I think 2 questions are enough. You have to remember this equation to solve MCQs. Okay.